This video is just really a quick summary of some of the issues I've had with the Upair ever since we got it. Myself and two colleagues bought the Upair last autumn, and both their Upairs are really good. They're very stable, they fly well, and even up to moderately windy conditions. Whereas mine, when it flies well, but other times I get zero SATs, so it becomes quite hard to control. I cover several topics in the video, and I imagine that a lot of you guys will know how to take the Upair to bits. You'll know some of the bits and pieces. So what I'll do is I'll put a summary on of the audio bookmarks or video bookmarks where you can jump along, and if there's bits you're interested in, it'll make the search a little less painful. And hopefully some of the problems I've had may be averted by this video. Okay, here we go then. What we have here is I've got an external connection coming out here just for a non-stop battery. It makes it easier to apply volts using these. It's one of those multi-star batteries, so I find them quite useful. They've got quite a long life and they charge really easily. Here's the kit I normally use for taking the bits. I've got some tape, extended USB cable, mouse, laptop, and some plastic tape. Got my magnifying glass, definitely helps to see inside the APM board. Range of tools, screwdrivers, a couple of flatheads, a couple of Allen keys. That one there's a 2mm hex head Allen key. Got the stock battery. And the little tub here I just used to hold all the screws and bits and pieces. I have lost about 4 already, so it's probably just as well I do that. Our controller. And the other batteries I've got, these are 2 multi-stars, a couple of multimeters. This one here I've just got a little breakout to get into the connections. It's really quite tight and very fiddly to get at. A pillow to support the weight of the quad, and I've got this little voltmeter which I use to check the value of the non-stock batteries. They're all LiPo balanced ESs. I'll not play the sound, but there's a live repeat. This just shows you each cell within the LiPo and the overall battery charge. So again, it's good to know just what you've got and what you're handling. So that's the sort of rough kit to get started with for disassembly. Here with the controller, everyone should be pretty familiar with the controls. RTL to the left, fully back for RTL, the forward, sorry. And on the right hand side, we've got the alt hold at the back. Middle position is GPS lock, and fully forward you get IOC headless mode GPS gimbal control to side. You've got the accelerator, yaw controls, left, right, etc. Again, it's just standard controls. On this one, it arms down and into the middle. I think it also does it for down and out to the right. I think I tend to contradict myself a bit here. So power up, in the back here you see this button allows you to cycle through the real channels to get the best reception when you bind with the quadcopter. Anyway, always put on the controller before powering up the quad. We've got my positive and negative extended connectors, so I can use the non-stop battery here. As you can see, it's hopefully going to pop in there. When that comes on, the gimbal's connected. That's the FPV transmitter coming back through to us. Quite often get that flash of the video recorder. Most important thing here is that you'll see that I can sit here for about 3 to 5 minutes, and that satellite search 0 will stay at satellites 0. The battery, you can see there's 12.17, 12.2, which is not bad. It's not fully charged, but I mean it shouldn't make a difference. because the way the internal wiring works, it should cater for battery down to 25%. Okay, to get the camera gimbal removed, just pop these grommets to the front. They come off easily. You access the cable, just pull the cable out, and then you can quite easily remove the back two grommets. Next thing I do is take off the aluminium cover for the radio transmitter, which is inside here. There's two 2mm hex head screws holding it together, one right and left. They come out quite easily. And that just reveals the board. Pull out the connector. You'll see the little aerial. There's a button connection on the edge there. Doesn't seem great, but it seems to work efficiently enough. Just take that off, and we're ready to continue with the disassembly. Get these 4 screws out, and that'll get the gimbal chassis off. Okay, with that off, that's the base removed. You'll see I've got my USB cable just hanging at the side. It's not very tight, I know, but it's been part of experimental stuff. And also you'll see that there's a hole I cut in the side of the fuselage just to drop it out. It's a lot of people make a nice job of that. I just nipped it out there. Next, just to slip off the compass connector in the leg there. It's an easy pull. The worst part about this cable is when you disassociate and split the carcass of the airframe, it's quite a difficult push through, but it does actually fit. So, okay, can now get the 2 bolts removed. One's a long one, it goes well into the carcass, and that was a short one which is just retained underneath the fixing. Just takes a bit of time, so we'll just skip ahead. Okay, so there's 4 screws or bolts into each motor. 1, 2, 3, 4. I think I've lost one in each one. The LEDs, there's also a retaining screw that goes through to hold the carcass together. They have to come out and multiply that by 4, and that should get us the disassembly point. Sometimes the Allen screw heads get stripped, they're quite soft. The way around it is to use I think they're called a torque head, a star shaped bit. I think it's an 8 or a number 8 that does it. It works really quite effectively, but at that point I would be looking to replace the faulty screws. With those screws out, it just leaves, there's 2 awkward screws in the housing there. There's a pin, there's a bar that went across there. Unfortunately, I broke it, so it comes out. So disassembly should be straightforward from now. Okay, so it splits, and at this point, push the cables, the compass cable, out through the various holes, and I've got my USB cable to get out as well. I'm just removing the LEDs there. I have a bit of tape just to hold them in place. That's actually for reassembly, not for any other reason. They tend to not sit in their fittings too well, but you'll get that one figured out. Right, that's the disassembly of the carcass. Get all the bits and pieces, move to one side. So this is the Upair motherboard or main board. You'll see mine is a version V1.1. They're not very tidy. The cables that go to the motors are quite tight. You can see the black one there is really tight, and just looks like it's going to cause problems in the future. What I have done to make disassembly possible, because with these motors connected like that, you'd have to desolder them to spin the motherboard. So what I've done is I've fitted connectors I've just split the cables and fitted connectors on two sides, so they just pop out, and that'll help release the motherboard. As I mentioned before, once I get the cable split, I've still got to get these two screws out from here. They're actually Phillips head, that's a flathead screwdriver. So the Phillips head will release them from there, and then I'll be able to flip over the motherboard. With the final screws released, it means I can get them out. I just like to pop out the screws here. Again, with everything in bits, it doesn't feel really comfortable. I just ping them out like that. That allows me to disconnect the motors and flip over the motherboard. So here we have it again, Upair 2 version V1.0.0.1, 216 the year, the month of 4. So, well, it's less than a year old. So I think it's manufactured by Upair themselves. The Upair flight controller board we'll see shortly. The first cables we'll look at are the one that comes off the main board to control the gimbal, which is this multi-core cable with connector here. Then the next one is comes off the board with 3 cores, a red, yellow and black, through a connector onto another extender, which is only 3 red cores. It's a 1-to-1 I think, so it's not a big deal, there's no crosses in the cable, so it just works. Here we have the actual radio transmitter, and it's aluminium casing. The back plate there gets very, very hot and difficult to touch. On this side here we have the button that allows you to select the channels for the radio transmitter to flick around. Now we've got the main board and the flight controller flipped over so we can get hands on and see what actually goes on here. The main input terminals here, I've got 2 external connectors on for an external battery, but typically expect to see between 12.6 and 12.4 volts on there. That's with a fully charged battery. So they feed down onto the main board, or the large board at the bottom. I'll just refer to that as being the power board, with voltages ranging between 12 volts and regulated down to just around about 5 volts. The 12 volt for control of things like the motors, etc. The upper board here is the flight controller board and bears a remarkable similarity to an APM 2 series board. There's a few subtle differences or slight variations from what you might see for an APM 2 or 2.5, but you'll see the Upair etching on the board just to identify it. Try and get a bit of focus here. The main thing to be aware of in the flight controller board is that it doesn't operate at 12 volts. In fact, if you apply more than 6 volts and any of the inputs to it, you're going to cause damage, irreparable damage. The way the board has been put together, it's got some blue grommets, light blue grommets as seen here, that stack it above the main power. As I mentioned, this is a 5 volt optimum VCC power supply coming from here in the red conductor, which feeds onto the live bus that goes all around the flight controller board. It is coming onto the board here. The blue wire I believe is ground. It's not black, but anyway, it's what it is. So that is a bus that goes round, and all the various modules pick their power supply off from this supply. I'll talk about a bit of regulation on that supply shortly. This is just an overview of what we've got on board. Here we have the compass connection that runs away across to the external compass that you can find located on the undercarriage leg through that connector there. The next connector we're going to look at is the connector that goes up to the GPS external module. Again, we've got 4 cores here, a red and black core, which provide the 5 volt supply, the red and green, which are the remote and receive and transmit wires. Here we have it's a Sericom L0048, and I've never been able to find a data sheet on this, although I will talk about that later when we talk about the GPS problem I had. The little arrow there, that should point towards the front of the aircraft, which is quite easy to do because the unit sits just in here in that little space there. So just align it with the front of the aircraft like that. This copper shielding, I just added that to try and help with the problem that's happened with the GPS receiver. I don't think it did any good. This is where the onboard battery backup was. It's a very, very small unit. It should be 3 volts or thereabouts. Here you see it to the side of a button battery unit that I replaced it with, I should say. It's a 3 volt one. I believe that it's there for a backup. It should operate between 1.5 and 4.5 volts, just to, I imagine, to hold the lock on satellites if the power supply was getting a bit low from the main board. Back to the flight controller. This here is the connection for the FPV from the flight controller board. Sending all the telemetry back to the Upair controller. Don't know what this cable's do. It's some kind of control for possibly hook up the gimbal. Here we have the USB. A lot of people talk about the USB mod. It's a micro USB that hooks up here and gives us an alternative 5 volt supply. But interestingly, the other thing it does is when you hook it up, it will interfere with the telemetry data channel. It diverts it from the FPV and puts it out onto the computer or the laptop to the APM software. All that happens automatically, and you will have seen the controller reporting no MAV data. The MAV data is actually the language or the protocol that the device talks to pass its telemetry and commands, etc., for the various changes in states we expect the device to carry out. Moving on, we'll look at the connection between my laptop and the quad using the software called APM Planner 2.0. Often referred to as Mission Planner, I believe. You can do a whole lot of stuff on Mission Planner. We'll just start it up now. Out of sight, I've got the quad connected up to an external battery, and it's currently running, I think, with 3 or 4 satellites. Now I've got to take the micro USB cable and hook it up to the laptop. In this case here, on the top right, although my pointer's not there, you'll see I'm using the port connection of USB modem. It's on a Mac, I believe, on a Windows computer. You're going to be probably finding COM port 6 is the COM port for connecting up. Over here on the left there's a whole lot of data. I've got to connect up the device first of all, so with the cables connected, I just click on the icon. Okay, so that's the cables connected, so here we go. That should connect it. You should see a message coming in the head-up display on the left-hand side when it initializes APM and starts to pull the data back. There we go. You should see, here we go. It's showing 5 satellites. It's centered on my house there, and some data about the latitude and longitude. We fling across here, there we go. No MAV data coming into the controller. The USB has interrupted the telemetry coming back on the radio, so all the control indications are now here. It's worth noting that if you change from alt hold to position hold on the controller, it does reflect back up. So the controller is still speaking, it's not receiving telemetry from the APM, sorry, the flight controller board. and you'll see I've got artificial horizon because my pillow's a bit squint and the quad's just lying on its side a wee bit. There we go, 7 satellites, 6 satellites. So it's drifting in and out. It's sitting on top of the table inside my house, so getting any satellites at all is quite amazing and very pleasing for me. Okay, you'll see the quad is running. The blue flashing light tells me that the GPS receiver is hooked up to satellites. You can see the flickering lights on the flight controller board. That's the transmit and receive. The red light to the bottom side of that is the power up one. The FPV transmitter has a light on also, you'll see that. They're green lights, you see, they're just the LEDs and perform as you'd expect. At this point you might think, well, what is your problem? You've got satellites, they're working fine. Well, we'll just go on to what I see the technical aspects of the problem I'm suffering with my quad and why I've got such an inconsistent satellite hookup. Now, just to demonstrate how we can get the alternative power supply up to the flight controller via the USB connection, you'll see here we are connected, top right, and if you look in the data fields, we've got well, no satellites yet, but we've got a voltage of 1.3. Well, that 1.3 is obviously measured from somewhere on the main board, because I know that we're putting 5 volts onto the APM board, so that's got to be going back through the circuitry to get down onto the main board. If you look here, there is no battery connected, but I have got the transmit receive power on there. I've also got the FPV connected, so it's trying to send telemetry back to the flight controller, but obviously nothing. I'm just trying to set the GPS module so it's in optimum position so that the ceramic block might pick up satellites for me. I paused the video there just for, I think it must have been 45 seconds, and we've managed to get 8 satellites onto the GPS unit. So that's not connected to the main board. That's, as you can see, it's the 1.34 volts, which indicates that there's no 12 volt supply connected onto the main board. So this is purely powered from the APM software via the USB cable into the flight controller board. Interesting development, I thought. Okay, get a bit more technical now. Here we see the power supply coming up onto the flight controller board. The red and the blue in this case is the positive and whatever ground. Over here on the GPS module, the cables coming up red and black are power supply VCC 5-ish volts. The module we have here is I believe rated at 5 volts. It should operate within plus or minus 5%, which would be an operating range of 4.75 volts to 5.25 volts. I've never found an actual sheet for this, but that's as close as I've come, which is why I believe the battery backup is normally 3 volts to hold the satellite lock. A bit of slow motion going on here just to allow me to talk over the video. Now the circuitry actually comes off the main power board. It goes through a Xenon diode here, a 6 volt Xenon diode, and that goes on to the positive VCC rail, which picks up the VCC for the GPS unit here, and that should power it as according to the design spec, which should hopefully be more than 4.75 volts, and certainly less than 6 volts. The Xenon diode taking the power from the main power board, being a 6 volt Xenon diode, will definitely protect from over voltage for the board, but that is coming from the normal power supply source. Now for some voltage measurement. Unfortunately, I found it quite difficult to measure, hold the voltmeter and film. So what you'll see here, you may not see all of animation of what I'm getting up to, but I think we can, yeah, we'll get the display in view. This is going to measure the voltage coming from the main board up to the APM terminal, 5.14. So it's delivering 5.14 volts, which you think, well, that's pretty good. That's certainly in excess of the 4.75 required on VCC to power the GPS unit. Next, I'm going to measure on the outgoing side from the Zener diode, which is in effect the VCC on it, flight controller. You'll see 4.79, 4.8. So we've lost 0.36 of a volt across the Zener diode, which I believe is normal, and that could have a bearing on my final conclusions. There we go, 4.73, 4.74. That was measured on the GPS module. Okay, so now we've dropped below what I believe to be the 4.75 volt threshold for the GPS to actually trigger. Because we're already up and running, it's held on to the satellites we've got there. I think it's also because it's not hidden behind a casing, it's open to elements. The next test I want to do is just to see what we're getting in the way of power supply from the USB. So I'm disconnecting the external battery. So I've lost my 12 volts onto the main board, the 5.14 volts that was going up onto the input module, and then effectively the 4.74 volts that was going across to the GPS unit. You'll see still got 12 satellites there, 13 actually, so that's powered entirely from the USB connector, which is connected to APM software. So 13 satellites in the top of the table is pretty good. The 1.29, 1.3 volts, again that's coming from somewhere on the main board, and that's obviously as a result of what's getting passed in reverse flow through the diode. If we look up here, we've got the flickering lights, we've got the transmit receive going on, the power lights on, and the blue flashing light is on the GPS module itself. So I'll try and get some measurements here. Again, it's a bit awkward. Right, let's see what we've got here. Can't quite see. Right, so you see there it's 4.83, 4.84, 4.82. That was at the coming in from the the micro USB, and it was going straight onto the VCC rail and picking up well, almost a 0.1 of a volt, but it's certainly enough to take it above the tolerance of what I perceive to be the operating characteristics for the GPS. There's a 1.89, that's on the side going down to the main rail. The other side, that's measured on the diode there. 1.8, yeah, 1.78. So that to me says that the 5.14 volts that goes up onto the APM board, converted down to 4.7, 75, 74 and flickering about, is borderline just not enough to trigger the GPS to search for satellites, the cause of my problem. So that sort of concludes my interpretation of where the issue lies. What I need to do is try and figure out a way of increasing the voltage coming up from the main power board onto the flight controller board. 5.14 is obviously not enough, so somewhere along the line I need to get probably 5.3, 5.37 volts. I'm not acquainted enough with the main power board or the electronic circuitry to do that. I'll have to do a bit more research, unless any of you guys can help and have any ideas. The last issue I was going to talk about is the actual voltage that the flight controller thinks it's getting from the device. We found that when I was flying at the same time as my friends, I was getting considerably less flight time, and the stock battery always seemed to be that much lower. Even when we bought the external batteries, we found it was quite a bit lower. By measuring the voltage on the terminals, we found that what was on the flight controller was not accurate. So we assumed that the APM board was actually taking a measurement from somewhere on the circuit board, and it was applying some kind of factor to it, which was displayed back in the telemetry, and that was also the value that made decisions like when to hit the RTL or emergency land or several of these things. So in this very, very quick and short demo, I'll go over what I did to rectify that problem. Okay, nice shots here of city of Perth. I think that would probably have been last October. Just to show that the Upair does fly sometimes. And that is a rugby pitch, not an American football pitch. So back to APM, go to the setup, find the battery monitor portion, click on that, and then once you get in there, there's two tabs, basic, advanced. Hit the advanced. In the measured battery voltage, you input what the battery measurement from a voltmeter is. If you watch the voltage divider, when I tab here, there you go, it's just changed now. This is actually applied to a formula from within the APM software, which takes the APM measurement and hopefully matches it up with the actual battery voltage. This made quite a significant difference to the flight time I've got, because the voltage divider that was in there before was way off, and when we put this in, it's increased my flight time by 15 to 20%. So that's pretty much it. That's the end of the sort of teaching, if you like. I hope it's been of use to some people, and if you've any queries, please get in touch. If you've got any comments, you want to point out inaccuracies, I also have no issue with that. It's all electronics to me, and I ain't an electronics engineer. I'm just an electrical engineer. Thanks, cheers.